So what is data? Let's understand what data is and how it can be of use in our lives. So here are 3 key points which kind of sum what data is, right? So the first thing is it's factual and observable unit of truth, reality. So whenever we talk about data, we are not talking of something that can be observed from with our eyes, or it's a fact, right? It's a fact. I mean, what is a fact? Fact is that something that cannot be argued on or debated further, right? Like, for example, I've given a few examples over here, but like, for example, the sky is blue. There's no debating that fact. It's a fact. Everybody, no matter who sees it, right? Most people, again, I'm not talking of the people who are colorblind or have disabilities, but 80-90%, even not even that, right? Most of the time, most people will see it as blue, right? No matter what. So that's a fact of observable fact that the sky is blue. Yeah, that's what data is, right? Data is that unit of truth which kind of gives us knowledge, gives us some sort of information, knowledge, and wisdom, right? So without that factual or unit of truth, which cannot be further tampered or argued, right? I mean, there's no debating. So we can all agree on, we may not agree on, let's say, the earth being flat or round or whatever, right? But we can definitely agree on that the sky is blue, right? So that's data. Yeah, I hope that makes sense. It's a factual and observable unit of reality. Okay, the second point is forms the basis of logical reasoning and analysis. Now, again, based on these facts, now comes the fun part, right? You can start to argue and make your points, right? What you call in logical reasoning, you call it arguments, premises, and conclusions. So based on your premise, you can make some conclusions, right? For example, the sky is blue, and because it's blue, and when it rains, the sky is gray, right? I've observed that with my eyes. So I can make a conclusion, argument, saying that when the sky is gray, it's going to rain, right? So that's a argument, right? So I'm doing some sort of reasoning, and then I present that to you, and you may agree or disagree with that. But again, the data is the same, right? We both observe that the sky turns blue and gray, and that's why we can kind of make arguments on it based on that fact, right? Based on the fact, blue and gray color of the sky, right? And then finally, the third point here is that it forms the basis of knowledge and therefore right action or wrong action. Again, in our sky example, if the sky is blue or the sky is gray, right, then you might say that your argument may be right, your knowledge of right action. When you say it's gray, you know it's going to rain, so you might as well take your umbrella, right? Or you're going to get wet in the rain. But if the data, somebody puts it as blue, then you think that, no, it's fine, I can take my umbrella, I don't have to take my umbrella. It's not going to rain. The system is telling me it's not going to rain. I can just go in there, right? So that's what data is. I hope I made that clear, right? Facts which cannot be disputed because it's widespread universal truth. That's what data is, right? The unit of science. Without data, there is no science, right? And what is science? Science is basically the pursuit of truth, right? What's science? Science is based, again, it's not just based on data, right? It's not based on data. Science is, with that true data, you take the right action. That's what science is about. It's not about any data, right? It's not about false data. Let's talk about the antitheses, right? Data and false data, truth versus misinformation. So if misinformation is fed in as data, right, then the whole system, the scientific principle or the systems of science that we build, right, whatever machines or computers or systems, they'll all fail because the data fed into them is not good data, right? It's false data anyway. So again, data is that factual and observable unit of truth, which is reality, right? We live in the real world. We don't live in a fantasy world. I mean, we can, but yeah, I mean, most of the time when you're living in the real world, something that we can all agree on, right? That's facts. So factual and observable unit of truth, right? Reality, which cannot be argued further again. Tampered, I mean, probably you can tamper it, but argued further. Let me see. If the sky is blue, you agree by yourself, right? Yeah, that's the sky is blue. Your family members, they can also agree on that, right? Yeah, the sky is blue. And your community or your suburb or your city, all the people in there also can agree that the sky is blue, right? And probably the whole world kind of agree that the sky is blue, right? That's blue. So that's the factual bit of it, right? Again, let's go and explain, understand this in more detail. So here, for example, let's in this example, we're going to just observe this fact, right? For human beings, plants are food and animals are food, right? That's very factual and observable reality. So we might see Aristotle kind of eating plants and animals, right? Which is vegetables and meat. But we'll probably not see him eat this, right? What is this? This is being money, right? For example, a piece of paper. He's not going to probably eat that. So I mean, it's not probably, we are 100% sure he's not going to eat that, right? Naturally, obviously, under certain kind of exceptional conditions, people might do whatever. But most of the time, right? He's not going to eat. He's going to eat this plate of food with meat and vegetables, but not this, right? Money. So again, if it's a factual and observable unit of reality, which we can factual. Sorry, it's a factual and observable unit of reality. That's it. Next, I mean, this same way we can kind of do kind of capture data for other animals also, right? Uh, what should I say? Factual and observable unit of reality. All right, so let's have a look, more detailed look at this, right? Factual and observable unit of reality. So let's have a look at this factual and observable unit of reality. For example, for humans, plants are food, right? Vegetables are food. Animals are food. I mean, we eat meat too. So that's a unit of factual and observable reality, which cannot be kind of argued. I guess most of the time you'd see people agree on it, right? That they eat this. For whereas in contrast, we can disagree that people. We can agree that people don't eat notes or what you call money, right? Money notes, whatever. Don't eat that, but we eat meat and vegetables, right? So that's true for us, yes. Whatever that species is humans, eats veggies, yes. Eats meat, yes. Eats money, no. So these are very observable units and factual information, right? Again, by the way, this is just a table that is kind of feeding or inputting or storing that data, right? So it's called a database table. Database is a computer word to kind of create these tables in a digital format inside the computer, right? So we'll have a look, we'll have a more detailed look at this, right? So for example, this table, I've hand drawn it, right? I've drawn it into a tabular format on kind of paper, right? Where you can observe it. But in this information is stored within a computer in a database table, right? Why? Because it allows us to leverage computer's processing power instead of our head, right? By collecting all these different types of data, we can make complex analysis or reasoning out of it. Like for example, AI, right? AI can look at what's that? Chat GPT. I think it looks at 1.85 5 billion parameters. So think of that, and then it comes out with their output, right? So that's how it is kind of made. So anyway, coming back to data, as you can see here, I've kind of captured those data points, right? These are observable units of truth. Eats meats, yes. Eat meats, no. Now, if you go to bears, for example, we see that, again, that's observable. Bears eat both vegetables and meat. So, right, yes and yes, right? Eats money, no. Again, they probably don't eat the paper, right? So for tiger, we have observed they eat veggies, no. They don't eat veggies. They eat meat, yes. They eat money, no, right? So these are, again, all different kind of data, let's call it data points, right? I mean, I won't call it a data point. So these are, again, data for different kind of species, right? Put into a database table or a table. Again, database table is in a computer format, right? So, yep. So coming to the second point, forms the basis of logical reasoning and analysis, right? What is logical reasoning? Very simply, it's premises and conclusions. Premise is something that you establish, right? If the sky is blue, then I conclude it's good to play whatever, some sport, right? So if then, that's the premise and that's the conclusion, right? This is a statement. You kind of, by the way, you format this in a computer kind of language, right? I mean, a lot of computer languages, this is called conditional logic, which is if then, right? If this condition holds true, if this premise holds true, then I conclude this, right? Whatever that conclusion may be, some action, or it may be just a setting of value or a state, right? Again, without getting too much into the details, right? Too much into computer kind of computers and computer logic. Just let's get into human logic, right? We logic very similarly. We make arguments saying that if the sky is blue, then I'm going to play soccer. If it's gray, then I know it's going to rain, so I'm not going to. So if and then, right? That's kind of how we do it. For example, let's take an example of food, right? Something we all can relate to. I guess everybody can relate to, right? Most of the times we do this, right? We can kind of frame this, frame this logic, right? If food X, whatever food X is, right? X makes me feel great, then I conclude, right? Then I conclude that food X is healthy. And whatever is great, again, great is just a word, right? But what it actually means is that your high energy levels, vitality, etc., right? So now let's try two different foods, right? Aristotle, he tries fish, and then he feels great, right? After eating fish, he feels really nice and strong. So he concludes that fish makes me feel great, then fish is healthy. So what's the conclusion of this? His argument, I mean, this statement holds true for fish, right? Whatever, food X. Now let's try food X to be donuts, right? Do donuts make you feel great? If donuts make me feel great, then donuts are healthy. And then he tries it actually, right? He actually tries it. That's the data point, right? That observable unit of reality. When he's eating fish versus when he's eating donuts. When he eats fish, he can observe it. And that's where this donuts, or what you call the fish, is healthy. But when he eats fish, what actually happens is that he feels sick, right? So he's kind of, nah, donuts is not healthy. So he makes that conclusion, right? But again, it's based on that observation data points, right? So based on the data point, he's making some logical conclusions of food, right? So which kind of leads us to our third key point, is that this logical reasoning from data, point one, data, point two, reasoning, point three is knowledge. This gives us knowledge. After we reason with the right data, then now he can conclude, right, that out of these two foods, he'll stick to eating fish and not donuts, right, for lunch or for whatever, for dinner, because he knows that's healthy. It doesn't make him feel sick, whereas donuts make him feel sick, right? So that's his knowledge. Now, he doesn't have to every day go, what's knowledge? You might ask, what's knowledge, right? Knowledge means you don't have to kind of test it out all the time, right? Once you have that, next time you go ahead, you see donuts, now you're not going to eat donuts because you've already confirmed it. All right? You've already confirmed it, that eating donuts doesn't make you feel healthy, so you're not going to eat donuts. So that's That's kind of your knowledge now. So again, I mean, think of it, right? Why do we need knowledge? I mean, imagine if you didn't have like a memory, right, where you can hold your insights, right? You'd go on making the same mistakes over and over and over and over again. I mean, I think that's not an intelligent thing, right? I mean, let's like we say, right, the brain of a goldfish, right? Goldfish don't remember things. They don't. They're not very smart, for example, or whatever. Some birds, for example, like ravens, are very intelligent compared to humans. No, sorry, compared to other animals, right? Even larger animals, because they're why they're intelligent. They have that capacity to accumulate knowledge, right? Some animals have that capacity to accumulate knowledge, whereas some animals have very short-term kind of memory, right? They forget everything and then they do that same thing again. They reset to zero kind of thing, right? So yeah, I think the more intelligent animal becomes, right, or a species become, their knowledge base becomes much larger, and they don't have to make the same mistakes over and over again. Anyway, so that's the third point, right? Forms the basis of knowledge, which leads to right or wrong action. Again, that's very important to understand, right? If we didn't have, if we kind of get the wrong data for some aspects of our life, right, then our action would be wrong, right? Because our knowledge would be based on that data, and then the actions we take would be wrong. For example, again, the things like eating food is very simple, right? We can observe it, see it, but some abstract concepts, right? Some abstract phenomena which we cannot complicated, or abstract phenomena which we can't observe ourselves. That's very important, and at that point in time, data is very important, right? Because I mean, I don't know what's going on in for example, some different country, right? Which I can live in only one place at one time, right? I cannot live in 50 different places. So I have to rely on data, like for example, videos or images from different countries, right, to understand what's going on there, right? So that's my data point. But if that data point is I get fed the wrong data, then my knowledge will be wrong, right? For example, let's take a country, right? We might think a country is very hostile, or it's a hostile country, or it's a backward country, and that's the data we've been fed, right? Again, I'm not there by myself. I'm relying on some source of data, whatever that is, and that gives me some sort of bias information, right, or misinformation or whatever, and that's how it forms my opinions, which is my knowledge, right? That's my knowledge about that country or that phenomena, something that I've not seen. Say for example, I've never been to the Arctic, right? I don't know what the Arctic is. All I know is what you have told me through this images, the things that I've seen, right? So again, based on that, I can take some action, right? I see snow. I think Arctic is like this. Okay, when I go there, I might take some action based on my the knowledge that I've accumulated from social media or something like that, right? So anyway, it's something to consider. Okay, I'm going back. Let's go forward. So again, yeah, I mean, this brings us to that key point, right? Data, sometimes it can be misdata or whatever, misinformation, or true data, or very kind of factual information, right? I think in today's day and age, we live in the age of misinformation, right? So that's something for us to kind of understand, right? True information and misinformation, because yeah, whatever. I mean, data has been thing. So again, just to summarize, right, visually, as in a chart, right, data is the units of reality. That's what we want to get, and data helps us reason, and the more complex phenomena that we want to understand, phenomena or something that we can't experience firsthand, right, we have to rely on data. For example, like I said, I haven't visited so many countries, right? I don't know what there is. I cannot just uh, be data that I have got myself, right? I haven't seen it with my own eyes from my own ears. I haven't heard it. I have to rely on somebody kind of telling me something about it, right? So that's, anyway. So if we get the right information, then I can make the right kind of reasoning. All right, the people there are like that, and then I do some right action, right? Whatever that action is. Maybe not for a country, but whatever, right? For example, if I make a preconceived notion, right, or a preconceived notion, what's that preconceived notion, right? It's basically getting some sort of wrong data. Wrong data gives us some wrong reasoning, and then we take some wrong action, right? So that's that whole thing, right? Data, that unit of reality. If you get fed wrong data, like they say in computer science, right? Garbage in, garbage out. Same thing applies to our minds too. If you get garbage in, then we get garbage out. And that makes us, garbage in makes us take wrong action, and that makes us unhappy, right? Whereas if we take the right action, our lives are better, right? That's why we get, that's what, I mean, if you think of it, right, that's what Buddha taught in his Eightfold Path to Spirituality and Wisdom. Right action, right data, or whatever he said, right? Right knowledge leads to, right information leads to, what do you call, right? No, what was it? Right thinking, right speech, right whatever, right? Right thinking. What's right thinking actually, right? It's right knowledge. Was it right knowledge? It was right knowledge too, yeah, sorry. Right knowledge, right? Right knowledge leads to a good life, is basically, I mean, just kind of summarizing it, saying right action, right knowledge, right thought, right action, right? Right knowledge, right thought, right action. So when you're saying right thought, right knowledge. So right knowledge, right? What's right knowledge, right? Knowledge is when you kind of look at reality as it is, right? That's what Buddha kind of taught. Look at reality as it is. That's where you get your right knowledge from. You observe what's happening around you. I mean, think of Buddha's kind of whole life journey, right? He observed, I think the three common things he observed was whatever, sick person, old age, and death, right? These kind of three aspects. His observation kind of made him try and understand reality as it is, right? But that led to his right kind of knowledge, and then right action, right? Whatever his action was, the whole philosophy that he taught, right? Positive outcomes, basically, not negative outcomes. So he said, if you don't take the right action, you take the wrong action, you make mistakes in your life, right? Mistakes as in, yeah, spiritually. Anyway, data, information, knowledge, wisdom, right? I mean, you need to be, that's the pyramid that we need to understand. Right at the bottom is data. If our foundation is weak, our whole wisdom will be weak, right? We'll have the wrong knowledge. We'll probably never get to wisdom, right? We don't say wrong wisdom. There's only wisdom. So if your data is wrong, your wisdom will be wrong too. Anyway, one aspect to consider here is, right, cameras don't lie, right? Humans do lie. That's a fact. And that's why in our kind of model, data is superpower model, right? We want to understand that we trust computer recorded data by some sort of sensors and not humans, right? Anytime there's human intervention with data, I mean, people often tamper data for their own benefit. That's something for us to keep in mind. Anyway, reiterating our key facts, key points. Factual data is the factual and observable unit of reality, which cannot be tampered or argued further, forms the basis of logical reasoning, analysis, and then forms the basis of knowledge and thus right or wrong action. And finally, now let's have a look in the context of complex system, right? Computers, right? Computers. That's where the word whole data comes in, right? Data is when any kind of information is stored on a computer, right? So let's see how data is collected, stored, retrieved, and processed. So first of all, it's collected through some sort of sensors, right? Some sort of machine sensors that collect factual data. Then they're stored in some sort of database in a data center, right? Data center is just like a really big kind of computer with a lot of storage space where It's stored in different kind of architectures. That's the storage part. And finally, there's the logical processing part of it, right? Computers via algorithms that do reasoning that a human would normally do. But computers, as you can imagine, right, they're much more faster than in these logical operations than human beings. I mean, human beings, we've got like a maximum capacity to think, I guess, right? Very logically. Although we've got intuition, that's a different aspect. Computers don't have that. But typically, when we have factual data, computers are great at processing it in some sort of way, right? Even like a small thing like a phone too, right, can process quite a lot of data. But again, for computers to process it, like now let's just look a bit more into depth into data storage, right? Data is stored in a form of a table. Very simply, it's just a table, right? A table, tabular kind of format. I'm sure you have seen Excel sheets, right? These are basically tabular format. For in this example, which I'm trying to allude to, is like a computer, what do you call a traffic signal system, right? What you could expect there is probably a vehicle number there. Did that vehicle jump a red light? Yes or no, whatever. And then the date and time and the photographical evidence, right? There's some photo that's been taken by this camera and that's stored in the database, right? And there would obviously be like lots of other fields, but I've just simplified it, right? It's just like four columns, four rows of data, right? So and these are the rows, right? These are rows. The horizontal ones are rows and the vertical ones are columns. So yeah, that's basically how a database table is. And these database tables, right? This I've done, like I said, very visually, but actually how it's stored within a computer is in terms of data structures, right? Which you can visualize obviously like with an tool like Excel. You can visualize it in tabular form, but inside it, in a computer, is stored in data structures, right? And into the databases for easy kind of processing. What is processing? Reading, writing, editing, deleting, those sort of activities, right? And you'd find, I mean, a few common data structures or what you call databases types are MySQL, MongoDB. Again, these two are very popular and there are like tons of others too, right? But again, we don't want to understand this whole series is not about going into the computer kind of details about it, but to kind of paint that 20,000 foot picture of what data is, right? And how data gives people superpower, right? Whoever have control of the data. Retrieval is through algorithms for retrieval. I mean, again, here I'm kind of just mentioning some of the depth first search algorithms, depth first search, binary search, dictionary search, and a ton of other searches too, right? Again, if you're interested, you can obviously look them up and see how they work. But the big picture is, right? Big picture is big data, right? Extremely large tables for analyzing, for example, the population of a whole country, right? Or maybe all of humanity, who knows, right? I'm sure there are some of that exist too. That would have millions of rows for or a single data set, like for a particular aspect that data is captured, be millions of rows. And in terms of size, there would be up to petabytes, right? What is petabyte? Is 1,000 terabytes. And those hard disks, the small kind of compact hard disks that you get, they are about, say, you can get these days around 5 GB, right? 5 TB, sorry, 5 TB. So if you divide 200 of them would be 1 petabyte. So you can kind of visualize in your mind 200 of those hard disks. If I stack them up, right, they would be at least, that's like 50, right? I think that would be like, let's see, that would be around 10. That would be around 10. That's 20. So you can imagine, right? 200 of them would be like 10 times this, right? So you can imagine, like this, that's just for one kind of big data table, right? In a database table, basically. And what's this useful for? It'll be useful for things like AI to process and extract patterns, right? With this large data that these machines have collected, right? The AI can understand and extract patterns which which should be much more than what a human can understand, right? I mean, think of this. Yeah, humans kind of can understand. Our limit of understanding would be to a certain level, right? But AI would be able to extract patterns that are much, some things that we cannot comprehend, I guess, is what I'm trying to say. So anyway, that's it for this video. I'll see you in the next one. Thanks.